Hi everyone, this is K.Hari Babu, working as Associate Professor in MLR Institute of Technology, Electronics and Communication. Today I want to discuss about problems on exponential and Rayleigh distribution density function. So generally, what are the applications in the exponential and Rayleigh? Exponential means mainly these will be used for some amount of power is received from the radars and to measure the raindrop sizes, and Rayleigh also used for noise purpose, and this is also related with the Gaussian distribution and density function also. So now we will see problem on the exponential random variable. See the statement: the power reflected from an aircraft received by the radar is described by an exponential distribution. So here he is giving some amount of power is received by the radar receiver, that is given as exponential, and the probability distribution function also given, PDF, that is fx of x is equal to 1 by 10 into e power minus of x by 10 for x greater than 0. So this is the given probability distribution function for exponential, and the average power also given as 10 watts. Now I want to find the probability that the power received is greater than the average power. So now first of all I need to find which one is the given random variable. Here, see here, the random variable is given. What I need to find? I need to find the probability that the received power. Now I am assuming the received power is assumed to be random variable. So that is exponential random variable. So now simply I want to find the probability of the received power must be greater than the average power. I need to find this probability value. If you want to do this one, means first of all I need to know what is the probability distribution function and what is the probability density function. See here, exponential probability distribution function, that is, if x is the exponential probability random variable, then probability density function small fx of x is equal to 1 by b into e power minus of x minus a by b for x greater than a and 0 for x less than a. So this is the probability distribution function. By using this one I can find probability density function, so distribution function, that is small capital fx of x is equal to 1 minus e power minus of x minus a by b for x greater than a. So this is the probability density function, this is the distribution function. So now we are moving to our problem. What we need to know? So here probability density function is given, small fx of x equal to 1 by 10 into e power minus of x by 10 for x greater than 0. So now assume this is the equation number 1, this is the equation number 2, this is the equation number 3. So these are the known values. So this is the given one. Now I need to compare equation 1 and equation 3. By using these two, I can find the constant values. Here a comma b are constants. Now I need to compare 1 and 3, means here a equal to 0 and b equal to 10. So now next what I need to do? Here I need to find the probability of the power reflected power is greater than average power, p of x greater than 10. See here, my minimum value is in this random variable, the minimum value is 10, the maximum value will be assumed to be infinity. Now I need to convert in terms of the distribution function. Simply we can write 1 minus p of x less than or equal to 10. See here, 1 p of x less than or equal to 10 means assume 10 will be taken as the random variable value x means. So by using this one I can write p of x less than or equal to x is also called as probability distribution function, capital Fx of x. So in that way, I can find that value, that is 1 minus e power minus of, here x value will be taken as 10, that is 10 minus a value is 0 divided by b value, b equal to 10. So now what will happen? 1 minus e power minus 1. So this is p of x greater than 10. See here, means now I need to substitute this value, means p of x greater than 10 means original function will be taken as 1 minus e power minus 1 means totally this will be getting as 0 point something 3 like that. So this is the finding the problem by using exponential random variable. So now we are moving to the next one. This problem is related to Rayleigh's random variable. So mainly this will be used for finding the noise for the band pass, that is white noise for the band pass filter, and similar, these characteristics also similar to the Gaussian probability distribution density function. So see here, the amplitude of the output signal of the radar system, that is receiving only the noise, is Rayleigh random variable with a equal to 0 and b equal to 4 volts. Here constant values are given. Next, what he is giving, the system shows false target detection if the signal voltage exceeds V volts, and we need to find what is the value of V if the probability of false detection is 0.001. So now here the constant values are given. First of all, I need to know what is the probability distribution and density function. See here, if x is the Rayleigh random variable, then probability density function fx of x is equal to 2 into x minus a by b into e power minus of x minus a whole square by b for x greater than a, 0 for x less than a. So this is the probability density function for Rayleigh's function. So now by using this one, I need to find probability distribution function also. See here, the probability distribution function fx of x is equal to 1 minus e power minus of x minus a whole square by b for x greater than a. So this is the probability distribution function. Till now we know what is the probability distribution function and what is the probability density function for Rayleigh function. Now we need to solve this problem. See here, a comma b values are given. I need to substitute those two values in this equation. We can get, that is small fx of x, that is probability distribution density function. Fx of x is equal to, here a equal to 0, b equal to 4 means we can get 2 into x minus 0 divided by b equal to 4 into e power minus of x minus 0 whole square by 4 for x greater than 0. So it will get 1 by 2 into e power minus x square by 4 for x greater than 0. So this is the probability density function for the given one. Now we need to find probability distribution function. See here, that is capital Fx of x is equal to 1 minus e power minus x minus 0 whole square by 4 for x greater than 0. So this is the probability distribution function for the given one. So now what I need to find, see here the statement. Here the system shows false target detection if the signal exceeds V volts. See here, So means here now my random variable assumed to be noise voltage, noise signal voltage is assumed to be my Rayleigh random variable. Now he is telling if the random variable exceeds V volts, then it will shows false target detection. And here, for example, if the probability of the false target detection is 0.001 volt, then what is the V value? See here. So now the probability of false target detection is 0.001. Then we need to find V value, that is P of x greater than V is equal to 0.001. Now we need to find V value. See here, P of x greater than V. What I am telling, I need to find the probability of the random variable from V onwards. I need to take my final value will be taken as infinity. So now I need to convert this value into the reverse way, that is 0.001 is equal to 1 minus P of x less than or equal to V also. So now see here, P of x less than or equal to V. So this is called as probability distribution function. We know already this one. So here instead of x we are using V only. So here I can write P of x less than or equal to V. First I need to find this value, that is P of x less than or equal to V is equal to capital Fx of V equal to 1 minus e power V square by 4. Okay, so now I need to substitute this value in this equation. What will happen? 0.001 is equal to 1 minus of, I know this value now, that is 1 minus e power minus V square by 4. That is 0.001 means we can write 10 power minus 3 is equal to 1 minus 1 plus e power minus V square by 4. Now plus 1 minus 1 getting cancelled, that is you can find this value means we will be getting as square root of 4 into ln of 1000. So this is the V value. So it will get that is 5.256 like that. So this is the signal voltage. Next one. This problem also related to Rayleigh's random variable only. See here, the lifetime of the system is expressed in weeks is Rayleigh random variable x for which fx of x, the density function is given as x by 200 into e power minus of x square by 400 for x greater than or equal to 0. The probability density function is given. Now what he is asking, what is the probability that the system will not last a full week? That is first one. Second one is, what is the probability that the system lifetime will exceed 1 year? See here, first of all, I need to identify what is the random variable in the given system. In the given system, so here, the random variable x will be assumed to be lifetime of the system. Now, what he is asking, you need to find the probability of the random variable, that is the system lifetime will not exceed 1 week. Now, first of all, I need to assume my lifetime of the system is assumed to be weeks only. That is, I need to find P of x less than or equal to 1. We need to find this one. See here, it is same as probability distribution function. Here already probability density function is given. Now I need to convert in terms of the probability distribution function. See here, that is fx of x is equal to 1 minus e power minus x square by b. So this is the for x greater than 0. This is the probability distribution function for the Rayleigh random process. So now what is b value? Here b equal to 400. Here b equal to 400. Now we can write fx of x is equal to 1 minus e power minus x square by 400. So this is the probability distribution function. So here now I need to find the system will not last a full week, that is P of x less than or equal to 1 also equal to capital Fx of 1 is equal to 1 minus e power, here x is 1, that's why 1 square by 400. So this will be getting as 1 minus e power 1 by 400, that also equal to 0.0025, like that. So this is the what is the probability that the system will not last a full week, that is P of x less than or equal to 0.0025. Next, we need to find what is the probability that the system lifetime will exceed 1 year. See here, he is specifying 1 year, but my random variable is considered in terms of the weeks. Now, I need to convert year into the weeks. So that is 1 year means that will be taken as 52 weeks. Now what he is telling, you need to find the probability of the system lifetime is exceed 1 year, x greater than 52. I need to find this probability. So that is P of x greater than 52. I need to convert this value in terms of the probability distribution function. I can write 1 minus P of x less than or equal to 52. See here, P of x less than or equal to 52. This is direct probability distribution function. We know already formula, that is capital Fx of x is equal to 1 minus e power minus x square by b for x greater than 0. Now I need to substitute this value in this equation. First of all, I can write this capital Fx of 52 is equal to 1 minus e power minus 52 whole square by b will be taken as 400. This is capital Fx of 52. Now I need to write in this one means that is P of x greater than 52 is equal to 1 minus of 1 minus e power minus 52 whole square by 400, that also equal to 1 minus 1 plus e power minus 52 whole square by 400 plus 1 minus 1 getting cancelled, that is e power minus 52 whole square by 400. So this is approximately equal to 0.00116. So this is the system will lost. This means the system lifetime will exceed 1 year. Thank you.